So I think in the last class we discussed about the nodal analysis, and I think we have seen some problems related to solving, that is reducing your resistance. Have you all completed that problem, students? Is there any doubt is there in the reducing the problem?
No, ma'am.
No. Sure, okay. So with that idea, we'll stop with that. So till now, we have seen two analysis. One is mesh, other one is nodal. For mesh, we have used KVL, and for nodal, we use the KCL. Okay, and as well as we applied the Ohm's law, and we got the complete result there. So now, next today's session, what we're going to do is, we're going to see the next theorem. That is called as an Thevenin's theorem. Okay. So that is what we're going to see today. Okay. Have you heard about the word Thevenin's theorem, students, before?
Yes, ma'am.
Yes. Yes, what you learned about that? What you heard about that? Any?
It is basically based on that voltage only. So basically, mesh analysis and all.
Okay. Where you have seen? Where you heard about these things, ma?
Ma'am, actually, I have done BEEE 1001 course already.
Oh.
And for JE, we have there, ma'am. I think it's like it's there in JE, a small part of JE, Thevenins and Nortons.
If you do BEEE 101, can you take BEEE 1001 also, ma? Is it that possible?
Actually, it's the core course for us, for CSE students, so we have to take it.
Oh. Sure, okay. There is no issue, means no problem.
BEEE 1002 score.
Okay.
Sorry,
Whether I'm sharing my screen?
No, ma'am.
No? Okay. Okay, this is a problem where we stopped with. Okay. So rightly what he was saying. So Thevenin's theorem is, again, this is one of the important, very, very important theorem to solve any problem. Okay. See, that's what again and again I'm saying this. For solving any circuit, we can apply any method we want. Okay, so in this unit, we are going to see about 4 methods to solve to get a solution for a particular circuit given. Okay. So in every time we are going to see different methods how to solve it, and finally, if you should be in a position to say that okay, which analysis will give you very fast result, and which for example, if I say generally give any problem, you should be in a position to solve it and get the answer very fastly by any method you want. If the method is not specifically given, then you have to go only by that method alone. So this Thevenin's theorem is that what it is saying is, if a very big problem is given, many resistors and many voltage sources and so many currents or something like that, many elements are there in the network, to get the equivalent value of that network, that is to find out the current, or to find out the current flowing through the element, or to find out the voltage across any element. So this method will give you an easy solution. But the way of getting the solution is going to be difficult only. But if you see the to ultimately to get for the bigger problems, this method will be very easy to get the solutions. Okay. So what this method is saying is, first of all of you listen properly. What Thevenin's theorem says is that if any circuit is given, first thing we have to see that what is the response element in the circuit. Okay. So what is my response element is, for example, what is the, for example, I'm going to say find the current flowing through the particular resistor, or find the voltage across this resistor. Like that, if I say, that resistor is going to be called as a response element. Is it okay, my students? So first of all, we have to identify what is the response element. So, okay. So after identifying the response element, very first step is we have to remove the response element. Okay, remove the response element from the circuit. So if I'm saying that I'm going to find out the current through a particular resistor, means what I'm going to do there is I have to remove that resistor. If I remove, what will happen, students? You will be having an open circuit created, isn't it? In that circuit, your circuit is given with all your resistors, voltage, current source like that. I'm going to remove one resistor because I want to find out the current through that resistor. I want to remove that resistor. Then what will happen? there will be an open space created, isn't it?
Yes, ma'am. Yes, ma'am.
Okay, so
Yes, ma'am.
at that point we are going to find out what is the voltage. Okay, so that we'll call as a Thevenin voltage. So what we are going to do actually in Thevenin's theorem is the entire circuit we are going to reduce to a simple Thevenin equivalent circuit where it has an Thevenin equivalent circuit will have like this, that is V Thevenin, and series to that we have R Thevenin. So if you have any bigger circuit, we are going to reduce a simpler circuit where it has V Thevenin, series to that has R Thevenin. So how to get this V Thevenin is, that's what we are seeing right now. So to find out V Thevenin, you have to first open the response element or remove the response element and find out the open circuit voltage or the voltage across the 2 points. That is called as a Thevenin voltage. The voltage across that point will give you the Thevenin voltage that we are going to place at this point, this equivalent circuit. Zero questions. Next, how to find out R Thevenin is, in the entire circuit, first you have to remove the response element. Okay, from that point we are going to see and find out the equivalent resistance of the entire circuit. So what we are going to do here is, if the resistors are there in the circuit, no problem. If there is any voltage source or any current sources available, we are going to replace that by the, there should not be any voltage source or current source. So how to do that? For example, if I have a voltage source, I'm saying that I don't want that voltage source to be in my circuit. So how to remove the voltage source?
Like by getting a equivalent voltage to it.
Okay, we're getting equivalent. But let us check that. I'm having like this, students. Okay, something like this. I have a circuit. I'm saying that I want to find out the current across. Okay, let us check R1, R2, R3. This is R4, and this is V and I. Okay, so let us assume I want to find out the current across R4. That is my aim. Means what I have to do first step is, first of all, I want to open the, remove that response element resistance. If I remove, oh sorry, remove the response element resistance means, which is the response element from right now in this circuit? Which resistor?
R4.
R4. First, we are asked to find out the current across R4. So first of all, we have to remove the resistance R4. So we will get a point AB. Okay. So across AB, we are going to find out the voltage. So VAB is nothing but your V Thevenin. That voltage only we call as an open circuit voltage. Okay, that is what we find out for the V Thevenin. Okay. Fine. Then for R Thevenin, what we have to do is, for R Thevenin, again the same like this, we have to remove the response element. After remove the response element, my entire circuit, I should have only resistance. I should not have any sources at all in my circuit. So I have to omit these sources. So how to do that is, if I have a voltage source, what we are going to do there is, if a voltage source is there, I'll be going for shorting it. If a voltage source is there, I'll go for shorting it. If I short it, whether any voltage will be flowing there?
No, ma'am, just a wire,
No.
normal
Okay,
wire.
it will be only a wire. So you are going to omit that voltage by shorting it. That is the reason why you short the voltage source. And if you have a current source, then what you have to do then?
Open circuit, ma'am.
You have to open it. If there is any current source in my circuit, I will open it. If you open it, only voltage you can find, current will not be there, isn't it? So that is why we go for opening the current source and shorting the voltage source. After opening the current source and shorting the voltage source, we'll then after that, for example, this circuit is there. What I'm going to do here is, I'm going to take out this voltage source and short it and open this current source. This is what I'm planning to do. Okay. So I'm going to short this one and here I'm going to open it. Okay, students. So then I'm going to find out the resistance across AB. I'm going to find out the equivalent resistance across AB by seeing from this point how the resistors are connected, whether these two resistors are in series and this is in parallel with this like that. I'm going to find out the equivalent resistance at that opened point of the response element. That is called as your R Thevenin. Getting some idea, students? Once you do the problem, you'll understand more. Whatever I'm saying right now, is it okay, students?
Yes, ma'am.
Okay, ma'am. So then, to find out the response value, for example, then to find out the R4, IR4, what we are going to do here is, we have an sorry, my equivalent circuit, I'm going to have V Thevenin and R Thevenin. Then I'm going to place the response element here. This R4 is my response element. I'm going to place this here because entire circuit I'm going to create a point AB by reducing it to the simplest circuit is V Thevenin R Thevenin. Then I'm going to place the response element here. Then I'm going to find out what is the current across R4 is nothing but V Thevenin divided by R Thevenin plus R4. That will be a current across the R4. That's how we are going to proceed for the Thevenin's theorem. So Thevenin theorem has 3 steps to do. First step is to find out V Thevenin. Next step is to find out R Thevenin. Third step is to put that in the equivalent circuit and find out the response element value, whether it might be a voltage or it might be current. Okay. Shall we go to the problem and see how it is happening?
Yes, ma'am.
Always I'll use a very simple problem at the starting. Then only you will understand the concept. Later on, we'll do some complicated problems and all. All of you note down the circuit. Okay. Find the question here is find the current flowing through 24 ohms using Thevenin's theorem. Okay, ma. This is a question. Find the current flowing through 24 ohm resistor using Thevenin's theorem. Have you all noted, students? Students?
Yes, ma'am.
Raghav, have you noted down the problem, ma? Balashiva, have you noted down the problem? Manideep noted. Okay, fine. So now we'll start doing the problem. Noted, ma'am. Okay, fine. So what is the first step we'll do, students? So we have to do by the Thevenin. So very first step is to find out what? First you have to do to find out V Thevenin. So V Thevenin, what is the first step you have to do? Remove what? Remove the response element. Which is the response element here?
24 ohm.
Okay, so 24 ohms you have to remove it. So first you have to draw the diagram also, students, because 1 mark will be allotted for the diagram. After opening it, you have to draw the diagram. So this and all will carry marks depending upon the problem weightage. So 10 volts, 2 ohms and 12 ohms. So this is a point AB. Okay. So from the point AB, we are going to find out what is the voltage at this point AB. It is nothing but your Thevenin voltage. Okay. So what will be the voltage across AB? It's nothing but across which resistor?
12 ohm.
It is across nothing but it is across voltage across 12 ohms. Isn't it, students?
Yes, ma'am.
What is voltage across 12 ohm?
Ma'am, by voltage division, like 12
Yeah,
into
you
10
can go by because only one voltage and 2 current source series. Take your V, then take the total resistance in series and then find out the thing. Or else, if you apply voltage division rule, one voltage source and 2 resistors are in series. If I want the voltage across one element, what is the formula? Voltage across 12 ohm is nothing but total voltage into which resistance? Do you remember, students?
12,
Total voltage is that resistance divided by sum of the two resistance.
14.
So voltage division rule says like that. Is it okay, students? It is nothing but the same concept. Okay. We're going to take the equivalent resistance, then take the 10 divided by this one. Voltage division rule says that. Yes, ma'am?
Why did you take divide by 12 plus 2?
The voltage division rule, ma. I'll say in the normal also we'll see. What is voltage division rule says? We have done what you see. If I have two resistors connected in series to one voltage source, if I want a voltage across one element, nothing but total voltage into that resistance divided by sum of the two resistance.
Got it, ma'am.
That is one thing. Another thing is, normally also you can do on SEMA. If I want voltage across 12 ohms, how do you do it is, first of all, you want to find the equivalent resistance. Equal resistance 12 and 2 are in series, isn't it, ma? Okay. Then find out the current. Current is nothing but 10 divided by 12 plus 2, isn't it? This is what the current flowing in this circuit. Yes or no, ma?
Yes, ma'am. Yes, ma'am.
Yes,
Then what is
ma'am.
the voltage across 12 ohm is nothing but 12 into that is resistance into the current will give you the voltage across that resistor. So 12 into this you will get that. So 12 into 10 divided by 12 plus 2. This is what the concept means exactly. So instead of doing all these 4 steps, we are doing with a single step using voltage division rule. Okay, all of you?
Yes, ma'am.
Okay, ma. What is the answer, ma? What is the voltage of the voltage value? What, how much you're getting?
8.57.
Yeah, 8.57 volt. Okay. So is this voltage VThevenin calculation is understandable, students?
Yes, ma'am. Yes, ma'am.
Okay. Because Thevenin is very, very important, students, because next we are going to see maximum power transfer theorem. There also basically first you use only Thevenin only. So if you know this, then two theorems you can understand. You know that in 4 theorems, compulsory mesh, nodal, Thevenin and maximum, compulsory you will be getting one question, 1 or 2 questions. So 2 question means either will ask questions in the mesh, nodal or Thevenin and maximum power like that. So compulsory somewhere this Thevenin will be coming into picture. So this concept you should know clearly. Okay, ma. If there is any doubt, even a small doubt, you can ask me then and there. So next step to find out R Thevenin, students. Again, R Thevenin, how to do that is, first step we have to remove the response element, listen to students. So remove the response element. We have to find, we'll have a point AB. What happened to the voltage source? Whether you'll open it or short it?
Short.
Voltage source should be shorted. That's all, very good. So just short this one. Okay, students. So this is 12 ohm. This is 2 ohms. 2 and 12 only. No. Okay. This is point A and B. So now from this point, we have to find out what is the resistance across the RAB. Is nothing but this is called as R Thevenin. So now you see, students, how these two resistors are connected. Whether these two resistors are in series or in parallel, how they are.
Parallel and parallel.
I can't hear one is saying series. What all about others?
Ma'am, parallel.
Parallel.
Parallel, ma'am.
Yes, ma. That's what. See, you see here from this point we are seeing from this end. If you see this one end of your 12 ohm, 2 ohm is connected. Another end of 12 ohm, 2 ohm is also connected only through wires. Okay. You can also read out like this, isn't it? This is 12 and 2.
Yes, ma'am.
Yes, so they are exactly in parallel. That's what you have to know the things. This is only 2 resistors, no problem. You might have some 5, 6 resistors and all. There you should know which are in series, which are in parallel. So now it is 12 ohms, see parallel to 2 ohms is the equivalent thing. That is 12 into 2 divided by 12 plus 2 or 1 by 1 by of 12 plus 1 by of 2. Anything you can do.
Yes, ma'am. 1.7.
How much? 1.7.
717.
Yeah.
Yes, ma'am.
Up to this, okay, all of you, VThevenin, RThevenin? Okay, so next, what is the last one? Whether we are completing a problem or anything else we have to do?
Ma'am, we have to do like we have to now
Draw the
connect the
equivalent
last.
circuit. Yes, ma. Equivalent circuit and put the add the Thevenin, response element and find out the current across 24 ohms. That is what our ultimate aim. Then Thevenin equivalent circuit we have to draw, that is V Thevenin, R Thevenin, and then series to that you have to put the response element. What is the response element value? So V Thevenin is, we got how much? 8.57. So this is 8.57 volt. R Thevenin we got 1.71 ohms. What about this resistor? What is this value? This is
What
the point
four
AB, ma.
four I
This
guess
is 24 ohms
24.
because we open this point, that's what the point AB. So this entire circuit only we are reducing as V Thevenin and R Thevenin. So now we have to add this resistor there. Fine. So our aim is to find out the current across 24 ohms. It is nothing but how these two resistors are connected now.
And why
series.
are they series? Why not parallel?
Which one? This 24 ohms you're talking about.
Yes, ma'am.
Actually, see, Amma, if I'm taking this entire circuit, I'm going to get a point like this AB by removing this resistor, ma. Across this point only, I'm going to find out the V Thevenin and R Thevenin. Now I'm going to attach at that point only my resistor.
Okay, ma'am.
So my point is here. So this is my point. Entire circuit, that's what I've written a point AB. Entire circuit I've reduced to V Thevenin and R Thevenin. So then I'm going to attach my resistor only at that point A and B, isn't it? From there only I removed it. By seeing from that point only I got V Thevenin and from that point only I got R Thevenin. Okay? The doubt is clear, ma?
Yes, ma'am.
Okay. So now since this is my equivalent circuit, so V Thevenin, R Thevenin, and then we have attached a response element here. So what is the current flowing here? It will be the current flowing across 24 ohms as well as your I across 7. So it's nothing but V Thevenin divided by R Thevenin plus RL. We call this as a response element or load resistor also. Okay, response element or other name load, because many books give many terms. That's what I have to give all terms so that you will be understanding it. They might call as a response element or a load resistors. Okay, sometimes they call source resistance like that. Okay. So now what is the V Thevenin value? Is 8.57. R Thevenin is 1.71. This is 24. So now what is this value?
0.33.
0.33.
0.33 amperes. I across 24 ohm is 0.33. This is what about the Thevenin's theorem. Okay. Normally also if I am asking you to find out the current across 24 hours, what you will do without Thevenin? Generally if I ask, you can say that these two are in parallel and it is series with this. Then you can find out the total current. Then find out the current across this element. Okay, like that if you do also, you should get the same answer. Whatever method you do, your current across 24 ohms should be 0.33 amperes only. Okay. So same problem, all of you noted down the same problem. Only change you make is find the voltage across 12 ohms. Okay. Next question is same problem, 1A, 1B. I'll give like this. 1A, 1B is same problem we are going to take. But I'm going to change my response element now. Okay. Sorry, it's all should be closed. So 10 volt, 2 ohms, 12 ohms and 24 ohms, isn't it? My question here is find voltage across 12 ohms using Thevenin's theorem. Find the voltage across 12 ohms using Thevenin's theorem. Is it okay, students, all of you? So what you are supposed to do now? Open which one?
12 ohm, ma'am. 12 ohm
12
resistor.
ohm and start doing. Find out V Thevenin, R Thevenin, get the value. Meanwhile, I'll take the attendance. Okay. All of you do it. Whether you want me to do that problem or you can do it, students, all of you? Why no response?
No,
Trying.
look at
Okay, it's trying to do. Okay. So maybe I'll take the attendance. Joel? Answer attendance, ma. Joel is not there?
Yes, ma'am.
There are. Vaishnav?
Present, ma'am.
Sriniket? Sriniket? Not there. Are. Sai Skanda? Sai Skanda is not there. See, now I'm taking attendance this time. If you put your registration number, then only I'll consider for the attendance. Okay. Sriram? Sriram Santosh? Harshad?
Present.
Okay. Ikjoy?
Present, ma'am.
Shakti? Shakti? Manav Gupta?
Yes, ma'am.
Akash?
I'm Shakti.
Present.
Shakti is also present.
Yes, ma'am. My mic wasn't turning on, ma'am. It's
Okay,
net-
ma, no problem. Manav is there?
Present, ma'am.
Okay. Akash? Not there. Shikar? Likar Shikar? Shravan Shai Kumar?
Ma'am, present, ma'am.
Who is present? Sai Kumar, huh?
Yes, ma'am. Seven plus.
Okay. Vishnu Sai Reddy? Vishnu? Janavi? Janavi? Ishan?
Present, ma'am.
Sanindya? Sanindya?
Excuse me, ma'am.
Yes.
In the given question, ma'am, we have to remove the 12 ohm resistor, right?
Yes, ma. Remove the 12 ohm resistor, find out the voltage at point, as well as the equivalent resistor at that point by shorting the voltage source.
Okay, ma'am.
Sanindya is not there, ma. Itish?
Present, ma'am.
Aditya? Aditya is not there, ma. Jeevan?
Present, ma'am.
Elena?
Present, ma'am.
Anish?
Present, ma'am.
Ashutosh?
Present, ma'am.
Pramit?
Present, ma'am.
Pratana?
Present, ma'am.
Yashwant?
Present, ma'am.
Okay, Shreyas?
Present, ma'am.
Anand?
Yes, ma'am.
Shakshi?
Present, ma'am.
Shakshi? Anush?
Present.
Okay,
Present,
ma.
ma'am.
Raunak?
Present, ma'am.
Aryan?
Present, ma'am.
Spandan?
Present, ma'am.
Joshua? Joshua? Taran Kumar? Sorry, Taran Gupta?
Present, ma'am.
Anmol?
Present, ma'am.
Manas?
Present, ma'am.
Bijoy?
Present, ma'am.
Nabiha? Nabiha? Samriddhi?
Present, ma'am.
Manideep? Manideep? Anurag?
Present, ma'am.
Juhi?
Present, ma'am.
Kahi Singh?
Present, ma'am.
Rehan?
Present, ma'am.
Neeraj Kumar?
Present, ma'am.
Harshit Gupta? Harshit? Yash,
Present, ma'am.
Ansh,
Present, ma'am.
Navnita Krishnan,
Present, ma'am.
Abhinavi,
Present, ma'am.
Ishani,
Present, ma'am. Present,
Matthew,
ma'am.
Present, ma'am.
Raghav,
Present, ma'am.
Raghav, Someshwar,
Present, ma'am.
Salvi,
Present, ma'am.
Shirag,
Present, ma'am.
Hitesh, 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 Adara, Shakti Shanmugam,
Present, ma'am.
Mrunmay,
Present, ma'am.
Delsi,
Present, ma'am.
Abhinav, Abhinav, Adamya,
Yes, ma'am.
Adimitra,
Present, ma'am.
Balashiva, Balashiva, only,
Ma'am, present.
yeah, I know. Angesh Kumar, Angesh Kumar is not there.
Ma'am,
Is it?
Ma'am, 20 BC 2843 present.
Janavi, yeah.
Yes, ma'am.
See, if you have any issues, Namai, put your registration number. Sriram, what is your registration number? I have to go and search. 20 BCT.
ma'am, 19 BME 0509. Can you hear me, ma'am, now?
Sriram Santosha. Sriram Santosha. Once again. Always Kai Sada is having problem with the mic.
19 BME 0509, ma'am.
0509. Once again, wait.
Ma'am, Sanidhya present, ma'am.
Ma'am,
Once again, wait, ma.
Sanidhya, ma'am.
Yeah,
Srinike Dixit present, ma'am.
Srinike Dixit present, ah. You just see, I'm just glancing, ma. If anybody is there, just say.
Ma'am, Sanidhya.
Janavi is present, ah.
Yes, ma'am.
Sanidhya, ma'am. Sanidhya.
Okay. Ah. And anybody else? Sai Skanda, Sriniketan, Navita, Nabiha, and Vishnu Sai Reddy, yeah.
Oh.
Vishnu Sai Reddy, where he is. Vishnu Sai Reddy, yeah. What's your registration number?
Ma'am, 2794, ma'am.
2794, ah. Somewhere you have to search, ah. Say, okay. So attendance is over now. "57 students. Only 51 is there in the attendee. How come 57 students are giving attendance? See, I'll check after this month they are downloading attendance and all. Okay, unnecessarily people, if you give attendance, then that will be a problem. So don't give unnecessary attendance. Don't create problems. Because I will download the attendance and check. So, okay, students, have you all completed that?
Yes, ma'am.
Because I have to download immediately. Check. What was the answer getting, students, for that?
8 volt.
Okay. First, what is the first step for finding VThevenin? Remove which resistor? 12 ohm resistor, you have a point AB here. 10 volt and 2 ohms on this 24 ohms. So VThevenin is nothing but across VAB. Okay, so it is across which resistor?
24 ohm.
Either it can be across 24 ohms or else this 10 volt and this 2 ohm drop also together also. Either this point or this step, whichever you want, you can take down that voltage. But the easiest thing is V across 24 ohm is easy. So I can go for voltage division rule, V across 24 ohms. So the total resistance is that resistance divided by sum of the two resistance. Applying V voltage division rule. So how much is the value? VThevenin.
9.3.
How much more?
9.23.
9.23 volt. The next step is RThevenin. Again, remove the response element. And then voltage source shorted or opened?
Ma'am,
Shorted.
open.
Shorted.
Shorted. Current only you should open. So AB point. So this 24 ohms and this is 2 ohms. So now how these two resistors are connected? Because we want
Parallel.
Yeah, we want across this point. Across this point, they are in parallel. Okay, so this is across like this. This is the point I want to find out the value. So because of it, these two are exactly in parallel. So 12 is in, 24 is in parallel with 2 ohms.
RTH is 1.84.
1.8, one second. RTH is equal to 24 parallel with 2 is 24 into 2 divided by 24 plus 2. 1 point, how much ma? 8.
85.
84.
Okay, 1.8485 approximations. Okay, so at last we have to draw the equivalent circuit of the thing. So VThevenin, RThevenin and RL. So this VThevenin what we got is 9.23. RThevenin what we got is 1.85. RL what is RL? Which resistor we have removed?
12.
12.
Okay. So now what is the question asked is find out the voltage across 12 ohms, isn't it? So how to find out voltage across 12 ohm? Current means VThevenin divided RThevenin divided by 12 ohms. So now voltage across 12 ohm means you can apply voltage division rule easily because one voltage source, two resistors are in series. If I want the voltage across this resistor is nothing but total resistance, that's 9.23 the circuit into that resistance divided by sum of the two resistance. Applying voltage division rule. Okay, students?
Yes, ma'am.
Is it okay, ma? Or else find out the current. Current is nothing but VThevenin divided by RThevenin and plus RL. Then voltage is into that resistance value. The same concept. 9.23 1.12 into 12 you will get. So how much is this voltage across 12 ohms?
Ma'am, 8 volt.
8 volt you're getting. You can use this one or you can find the current across 12 ohm is equal to VThevenin divided by RThevenin plus RL. Same formula, the two different ways, steps you are going to do. 9.2 divided by, it is I across 12 ohms. Then V across 12 ohm is I across 12 ohms into R. So it's nothing but 9.23 divided by 1.85 plus 12 into 12. Instead of these, all these steps, I am putting one step with voltage division rule. Okay, students, all of you got these answers? Any doubt in this small simple problem of your VThevenin?
No, ma'am.
No, ma'am.
No, ma'am.
Can you please show the
You
next
want,
page?
you want me to show you this page? So, okay, I'll give one problem to do it as an homework. You can do it and come later. We'll discuss some other problems. Okay. Shall I go to the next page, ma?
Yes, ma'am.
Okay, ma. So now down the similar to this, the one problem I'll give you, so that you'll get a practice of this.
Ma'am, I have a class.
Yes, ma'am, that's all. I asked you to only note down the problem and go. Class is only at 3 o'clock. Or lab. Lab starts only with 3:50, no? Lab is only with 3:50. Wait. 2 to 3:41 lab. 3:50 only on lab. Just note it down firstly. My class ends up to 2 to 2:50 is my class, ma. Okay. Now time is only 2:45. So they note down this problem. Find the current across 3 ohm using Thevenin's theorem. So this is the problem given. Okay, note down this current across 3 ohm using Thevenin's theorem. Okay, students, have you all noted down?
Yes, ma'am.
Okay, do this problem and come. Rest we'll see in the next class. Okay, we'll stop with this.